In this section, we're looking at matrix operations. Operations are the addition, subtraction, and multiplication of matrices. There is no division of matrices. We can talk about the matrix inverse, which we'll do that in a future video, next section. But in this section, we can see how we can add, subtract, and multiply matrices. And there are two different types of multiplication. There's a scalar multiplication and a matrix multiplication. We'll look at the scalar multiplication in this video, and then we'll look at the matrix multiplication in the next one. But first, adding, subtracting matrices. This is an easy concept. We're just simply adding the corresponding entries in each matrix. Now, we do have the requirement that the two matrices must be the same size. So when we talk about the size of a matrix, we're counting the number of rows and the number of columns. So in this example that we have, we're adding two matrices. You can call this matrix A and matrix B. Matrix A, we count the number of rows. We have 1, 2 rows. So this would be a 2 by the number of columns, 1, 2, 3. This would be a 2 by 3. And of course, matrix B also has 2 rows and 3 columns. So both of these are 2 by 3 matrices, and you must have the same size matrix before you can add or subtract them. So since we have the same size matrix in this case, we can proceed with adding these together. All right, and we said that all we're doing is we are adding the corresponding entry. So we're going to take that first entry in the first row, first column of matrix A, and add the first row, first column entry in matrix B to get 1 plus 1, 2. And we'll do the same thing for the second entry in the first row. We'll add 3 plus 4 to get 7. And we'll continue doing that same procedure, just adding those corresponding rows. 4 plus 3 is 7. Negative 1 plus 6 is 5. 2 plus 1 is 3, and 0 plus a negative 2 is negative 2. It's as simple as that. If we were subtracting these, we would do the same thing. We would subtract each corresponding entry. Okay. All right, now there are some properties that we are interested in that we want to pay attention to when we're adding these matrices. The two properties involve the commutative property and the associative property. Now, the commutative property is when you switch the order of your sum. This commutative property tells us that A plus B will result in the same matrix as if we were adding B plus A. So it does not matter the order of where you're putting these matrices, you'll get the same answer. And you can see this. This is the same example that we had in the previous slide. And in this second example, all right, I've just switched the order. This was A plus B here. In this second case, I've switched the order B plus A. But you can see when we're adding each corresponding entry, you know, they're the same. Right? Whether we're adding A plus B or B plus A, we're still adding 1 plus 1, which is 2. And again here, whether you're adding 3 plus 4 or 4 plus 3, you're still going to get 7. So it does not matter the order of those matrices because we're just adding real numbers. And so adding matrices inherits the addition properties of real numbers. All right, the second property is the associative property, and this is an order to it. Right, if you've got 3 matrices A, B, and C, if you add the matrices A plus B first and then add C, or if you add B plus C first and then add A, that will result in the same matrix. And again, that's because the real number system has the additive associative property. So does the matrices will have that addition associative property as well. Okay, so addition, subtraction, straightforward there. The other operation that we'll see in this video is the scalar product. This is a multiplication of matrices, but not a matrix times a matrix. We're going to multiply a matrix times a scalar, and scalar just being a real number. right? So we're just multiplying a matrix times a number. And when doing the scalar multiplication, the scalar product of matrices, we're simply multiplying that scalar by every entry in the matrix. All right, so for example, if our matrix A is this 2 by 3 matrix 1 3 4 negative 1 2 0, and we're trying to find 3A, in other words, we're going to multiply this matrix A by the scalar 3. So we're multiplying every entry by 3. 1 times 3 is 3. 3 times 3 is 9. 3 times 4 is 12. Negative 1 times 3 is negative 3. 2 times 3 is 6. And 0 times 3 is 0. And that would be our matrix 3 times A. Okay, so scalar product is straightforward as well, just like addition, subtraction, very straightforward. Now, in our next video, we're going to look at the multiplication of matrices. When we multiply a matrix times a matrix, that's not as straightforward. Maybe a little bit more thinking will need to go into that, but we'll break that down to where it's very understandable.